All right, here we go. Unit 3, Section 2, exterior angles and third angles. So when we extend the sides of a triangle, we get some new angles that are formed called interior angles and exterior angles. So hopefully you can see here the interior angles obviously are on the inside of the triangle. The exterior angles are going to be on the outside there. Hopefully you can see the different color shading that they have for you. So let's just do some work here. Find the value of x. So first of all, there's always 180 degrees in a triangle. So if I give you excuse me, if I give you two of the sides, so we have 85 and 75, we know that there's 180 degrees in a triangle, minus the 85 we already know, minus the 75 that we already know. We have 20 degrees left over. So that means that that angle is 20 degrees. And then if you look at these two angles, they form a linear pair. So we're bringing back the vocabulary from last unit. A linear pair is 180 degrees. That means that x here has to be 160 in order for those two to make a 180-degree straight line. Okay, so we found x. X equals 160. Over here, kind of the same thing. So we have 180 degrees in the triangle minus the 58 right here and minus the 19 right there. And that gives us a total of 103 degrees left over. So we're going to say that right here, this angle is 103. Add them all up, you should get 180 degrees inside the triangle. Now, again, these two angles form a linear pair, so we have a straight line. So, in order to get 180 degrees, that means that x has to be, should pick a different color here. X has to be 77. All right, and then the last one would be the same thing. You can go ahead and try that one if you would like. But we can do this a little bit easier. We have what's called the exterior angles theorem. The exterior angles theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So if you take a look here at this visual, we really don't even need 3 here. All we care about is that the measure of angle 4 equals the measure of the opposite angles, the angles that are not next to angle 4 there. So angle 3 was next to it, so I scribbled it out. It has nothing to do with the exterior angles theorem. So we'll take the measure of angle 1 plus the measure of angle 2, and we get the measure of angle 4. So here's how we can put it to work. So here's my exterior angle. So we can say that 3x minus 22 equals the sum of the two non-adjacent angles. So that would be 80 and x. So if I add 80 plus x, I should get that exterior angle. Okay, so let's do a little algebra here. So subtract x. 2x minus 22 equals 80. Add 22. 2x equals 102. Divide both sides by 2. And x equals 51. So instead of doing all this work like we did up here, we could have just used the exterior angles, exterior angles theorem. So let's practice it really quickly. So we can say, let's see if we get 160. I'll put it right here. So x equals 160. That's what we got the first time. So if we use the exterior angles theorem, we'll say the exterior angle equals the sum of the two non-adjacent. So that would be 85 and 75. X equals 85 plus 75. So that means x equals, and we do end up getting 160 again. So for that one example we didn't do, go ahead, practice the alternate exterior angles theorem. And then we have the third angles theorem. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So now we're looking at two different triangles. We're saying the angle B here and angle E are congruent. That's what the one arc means. And then we have two arcs here and two arcs here. So that means those angles are congruent. And then it's saying that if that's true, then the last piece of information would be that angle C and angle F are also congruent. And why does that make sense? Because all three angles of each triangle are 180 degrees. So they have the same number of degrees left from the 180. So now I want to just take a look at a couple of things. First of all, we need to know that all triangles are 180 degrees on the inside. Yeah, and then I want to talk about three properties we're not going to use now. They have nothing to do with what you're doing right now, but we're going to get into these with proofs, I believe, maybe even next week already. But the first one is called, oh my goodness, the reflexive property. The second one is called the symmetric property. And the third is called the transitive property. So just add these somewhere on your notes. We just want to make sure we have them again for later. It was something actually that we normally would have discussed in Unit 2, but we decided to pull it and put it into Unit 3. So here is what each of these look like. Starting with the reflexive property, it's as simple as saying something like A equals A, or a number equals itself. You know, so if I were to give you an example, so we'll go name, property, and example. So if I were to give you a numerical example, we could say something like 5 equals 5. That's it. The symmetric property basically says that if there we go. If A equals B, then B equals A. Crazy stuff. Basically saying it doesn't matter if we have, it doesn't matter what side the equal sign they're on, is basically what they're saying. So, yeah. And then the transitive property, I'm not going to give a numerical example. This will all make more sense. Like I said, when we get into proofs, the transitive property says that if A equals B and B equals C, then we can jump from A to C. We can say that A equals C. So just put those down again. We'll talk about those more later in depth, but just something I wanted to make sure to cover. And that should take care of section 3.2.